We're going to practice the chain rule again, some more complicated examples. So I'm going to give you a position function. Let's say S of t is equal to t cosine of pi minus 4t. And I want you to find S of 0, V of 0, and A of 0, which is the initial position, initial velocity, and the initial acceleration. Initial position, velocity, and acceleration. All right, first of all, S of 0 is just 0 times the cosine of pi. When you plug in t equals 0, so 0 times the cosine of pi is equal to 0. So the initial position is at 0. That was pretty easy. Now let's do V of t, which is the first derivative of S of t. So V of t is equal to S prime of t. And we have a product rule here. You might want to try this one on your own. Actually, I'd really like for you to shut the video off right now and try it on your own and see if you can match up with my answer at the end. So we have a product rule here which says first times the derivative of the second, so t times negative sine of pi minus 4t, and the chain rule says you have to multiply it by negative 4, plus the second times the derivative of the first, and the second is cosine of pi minus 4t, and the derivative of the first is just times 1. So if we clean this up, V of t is equal to negative times negative is positive, 4t sine of pi minus 4t plus cosine of pi minus 4t. So there's your velocity function. And if I want the initial velocity, V of 0 is just 4 times 0 times the sine of pi plus the cosine of pi minus 0. And this becomes 0 plus cosine of pi is negative 1, so the initial velocity is negative 1. And I haven't given you any units, so it could be feet per second, I guess. It doesn't say, though. Now, the acceleration is the velocity's derivative. So we're going to take this velocity function right here. We're going to take the derivative of this. So we have a product rule again, 4t times the sine of pi minus 4t. And then we have to add to that the derivative of the cosine of pi minus 4t. So here we go. The acceleration is first times the derivative of the second. The derivative of sine is cosine pi minus 4t, and the chain rule says multiply it times negative 4, plus the second, which is sine of pi minus 4t, times the derivative of 4t, which is 4. And then you have to add on to that the cosine's derivative, the cosine of pi minus 4t. So that will be the negative sine of pi minus 4t times negative 4, says the chain rule. And if we clean this up a little bit, we have negative 4 times 4 is negative 16t times the cosine of pi minus 4t. And then we have 4 times the sine of pi minus 4t. And then we have a negative times a negative, which is a positive. So we have another plus 4 times the sine of pi minus 4t. And you can see that we have like terms here, sine of pi minus 4t and sine of pi minus 4t. They're like terms, so you can just add them together. 4 plus 4 is 8. So our final simplified A of t is equal to negative 16t times cosine of pi minus 4t plus 4 is 8 sine of pi minus 4t. And if you wanted to find the initial acceleration, a of 0, you just plug in 0 for t. So this first term is just negative 16 times 0, which is 0. And then we have 8 times the sine of pi minus 0. But the sine of pi is 0, so this is just 0 plus 0, which is equal to 0. So the initial acceleration is 0. So that's just kind of taking a couple derivatives in the disguise of position, velocity, and acceleration. We'll do a couple more of these. Let's say we want to do the same thing, find the velocity and acceleration given s of t is equal to 4 over 3 pi times the sine of 3t plus 4 over 5 pi times the cosine of 5t. Well, s of 0 is just equal to, well, this becomes the sine of 0, and the sine of 0 is 0. And over here, this becomes the cosine of 0. Well, the cosine of 0 is 1, so we have 4 over 5 pi times 1. So the initial position is 4 over 5 pi. S prime of t is the velocity function. So when we take the derivative of this, 4 over 3 pi is just a constant. So make sure you don't treat this as a product rule. This is a constant. It's like 4 times the sine of 3t. So don't use that product rule on this first term when you take the derivative. So what we're doing is we're taking the derivative of the sine of 3t, which has a chain rule in it, and multiplying it by 4 over 3 pi. So we have 4 over 3 pi. The derivative of sine is cosine of 3t, and the chain rule says we have to multiply it by 3. So there's the derivative of that first term, and we have the same situation here. 4 over 5 pi is another constant, so we'll just say 4 over 5 pi times the derivative of the cosine of 5t, which is the negative sine of 5t, and the chain rule says multiply that times 5. And now to clean this up a little bit, we have a 3 in the denominator and a 3 in the numerator over here, which will cancel out. And so what we're left with is 4 over pi times the cosine of 3t. And over here the same thing happens. We have a 5 in the numerator and in the denominator that'll cancel out. So we're left with 4 over pi times negative, so I'll put a negative right up to next to that 4, negative sine of 5t. And if I want to find the initial velocity v of 0, I just plug in 0 for each one of these t's. Well, the cosine of 0 is 1, so that becomes 4 over pi times 1, minus 4 over pi times the sine of 0 is 0. So what I have is 4 over pi is the initial velocity. Now if I want to find the acceleration, a of t, that's just equal to the derivative of the velocity function, which we have up here. And again, we have a constant, 4 over pi. Oh, this looks a little blurry. Let me see if I can focus this a little bit. There we go. So we have 4 over pi. The derivative of the cosine is the negative sine of 3t. Chain rule says times 3. And then we have minus 4 over pi. The derivative of the sine is cosine of 5t. Chain rule says times 5. And then to clean this up, the acceleration is 4 times 3 times negative is negative 12 over pi times sine of 3t. And 4 times 5 is 20. So minus 20 over pi times the cosine of 5t. And now what we have, we can take the initial acceleration by just plugging in 0 in for t. Well, the sine of 0 is 0, so this term will just go to 0. And the cosine of 0 is 1, so this is just negative 20 over pi times 1. Negative 20 over pi. There's your initial acceleration. Oops. Next example. Let's get away from velocity for a minute. Let's just do r of theta. I'm giving you different variables, so you're not always used to x and y, because sometimes you'll have different variables like r and theta. Let's say r of theta is equal to 2 theta times the square root of secant of theta. And you're just asked to find dr d theta. That means the derivative of r with respect to theta. That just means theta is your independent variable over here. So if you like x's and y's, you can call this y, and all those thetas, you can call them x's. It's the same thing. So let's just rewrite this because we have a square root. So r of theta is equal to 2 theta times the secant of theta raised to the 1/2 power. Well, we have a product rule here. First times the derivative of the second plus second times the derivative of the first. So dr d theta, using that product rule, is first 2 theta times the derivative of the second. Well, we have a chain rule here, so we have to multiply that 1/2 times the secant of theta to the negative 1/2 power. That's the outer function. But the inner function says that we have to multiply that by the derivative of secant. Well, the derivative of secant is just secant of theta times tangent of theta, and it's positive. Okay, so here we go. First times the derivative of the second. And now we have to add to that the second times the derivative of the first. Well, the second is just secant of theta raised to the 1/2 power. And the derivative of the first is just 2. So there's your product rule with a chain rule in there. The 2 in the numerator and denominator will cancel out. Now we have a situation where we have, all of these are multiplications. This is just factors. So we have theta times secant of theta to the negative 1/2 times the secant of theta to the first power, and the rules of exponents say we can add those two exponents together. So that's what we're going to do to simplify this. Dr d theta is equal to theta times secant negative 1/2 times secant to the first is just secant of theta to the 1/2 power times the tangent of theta. And you're going to add to that the secant of theta to the 1/2 power times 2. So you usually put the 2 out in front. And now what we can do is we can factor out this secant of theta to the 1/2 power because it's the common factor here. So secant of theta to the 1/2 power, which is just the square root of secant, times theta times tangent of theta plus 2. And you can just do the square root of secant of theta here, times theta tangent of theta plus 2. And that would be dr d theta. And if we wanted to get dr d theta when theta is equal to 0, if you plugged in 0 here, the secant of 0 is 1. So this would be 1 times 0 plus 2, which is 1 times 2, which would be 2. So if you have an initial value here, it would be 0. It would be equal to 2, sorry. So that's that. And then we'll have one more example. Let's find a second derivative of something real fun. So let's say we're given y is equal to 9 tangent of x over 3. And I'm going to ask you to find the second derivative, y double prime. Well, the first derivative, remember this is not a product rule because this is just a constant out here. So it's just 9 times. The derivative of tangent is secant squared. And this is a chain rule, so it's the secant squared of x over 3. But then you have to multiply that by the derivative of x over 3. Well, x over 3 is the same thing as 1/3 x. Hopefully you know that. And the derivative of 1/3 x is just 1/3. And that's it for the first derivative. So if we clean this up, a 9 in the numerator and a 3 in the denominator would change to a 3 here. So what we have is y prime is equal to 3 secant squared of x over 3. And that's it for the first derivative. But now we have a very complicated situation here where we're going to find a second derivative, which is the derivative of this. Well, what we have is we have the 3 on the outside. I'm just going to drop that 3 down. But now we have to find the derivative of secant squared of x over 3. We have a chain rule twice. So 2 chain rules. And how does that work? Well, first of all, we have an outer function which is just x squared. Right? We've got a secant squared of something, so the outer function is x squared. And then we've got an inner function, which is, what are we squaring? We're squaring the secant of x over 3. So the inner function is the secant of x over 3. So we're going to have to and then we have to multiply 2 secant of x over 3 times the derivative of the inner. Well, what's the derivative of the secant of x over 3? Well, the derivative of secant is secant times tangent. So we're going to multiply that by secant of x over 3 times the tangent of x over 3. And then the chain rule says we have to multiply the derivative of the secant by the derivative of this inner function, which is x over 3, which is 1/3. So this gets very complicated sometimes because we have an outer and an inner, and then when we take the derivative of the inner, we have another chain rule taking the derivative of the secant, and then the chain rule says times 1/3. So hopefully I've got enough parentheses here. And now it's just time to simplify this down a little bit. These are all multiplied together. There are no terms. There are no plus or minuses in it. So it's just 3 times 2 times this. They're all multiplied together. So the 3's will cancel out, 3 in the numerator and denominator. And then we have 2 times secant of the same angle. So if you have a secant of x over 3 times a secant of x over 3, it becomes a secant squared of x over 3. So y double prime, which my pen is running out of ink, y double prime is equal to 2 times the secant squared of x over 3 times the tangent of x over 3. And that's pretty complicated, but hopefully we can get some more practice on some problems like this tomorrow in class. Chain rule, sometimes you got to go through it twice. See you tomorrow.